Okay, team, I think I am live. How are you guys doing this Sunday morning? This is definitely still labeled as Saturday morning science, but I hope you guys are doing well on this lovely Sunday. I am double checking that I remembered to turn on monetization for this live stream. So give me a second because that's a YouTube setting. Um, Okay, dashboard, maybe content. Yeah, I'm super sorry that I missed yesterday. Um, I legitimately, legitimately slept 12 hours and woke up at 11 my time. I was like, well, I guess I'm not going live. Um, so, yes, I definitely needed it. I did find out, guys, that I have passed the written portion of my general exam. If you guys don't know what a general is, some PhD programs will call this a quals or something else. But what it is there's kind of three stages to a PhD. One is when you're taking classes, and then once you finish your classes, there's some sort of measurement or exam or oral qualification board, or combination of those things, to be like, yes, you did in fact learn things and have adequate knowledge and know how to be a scientist, or how to be a researcher for more broadly PhD. Um, and once you finish that, then you're sort of all but dissertation. So that's I have my oral board part of this excitingness on Wednesday, and then as long as that goes well, right, I'll be all but dissertation. So then I just gotta write up some of the research I've been doing, and it'll be that'll be a really great place to finally be. I have recolored my hair. If you didn't notice, last time it was very blue. I did not dye it blue. I had dyed it green, and it faded to a very pretty blue. But I like my uh, listen, my final form as a swamp witch is almost realized. But yeah, for this happy Sunday morning stream, I've got my coffee. I just ate my oatmeal because I thought it would be weird to have like my Lucky Charms on screen with y'all. I don't know what that would do to audio, but I hope you guys have whatever your favorite childhood cereal is. Um, I hope you've got a great big bowl of that. I definitely remember a time in college because I was never allowed to have specifically Cocoa Puffs as a kid. That was where my mom drew the line with breakfast cereals being like, no, it's just chocolate. Absolutely not. I'm not dealing with a hyped up 5-year-old, right? So I definitely remember a time in college when I ate so many Cocoa Puffs because I could. Anywho, so I hope you have Cocoa Puffs on this blessed day. Okay, um, let's see. Channel news. I'm working on. I'm trying to make sure that I do a live stream a week. Getting back to doing that. Obviously, I don't have any new science explainer vids up. I did write a bunch of scripts this week, but as I'm sure you guys can understand, it's been more than a little hectic with the general exam and PhD and life and stuff. Definitely got a lot of life stuff going on. That I am not comfortable sharing right now, but I will share in the next few weeks. You guys will know what's up. Anywho, okay. But let's see. This coming Wednesday, if you guys want to see me in a completely different context, I'm the dungeon master over for a Dungeons and Dragons 5th edition live streamed game on Cheshire Vic's channel. It's Guns, Magic, and Steel. If you YouTube search Guns, Magic, and Steel, like our playlist will come up. You guys can watch me DM for a bunch of other science nerds. So Dapper Dino's on there, and Got Sick Gibbon, and got Erica's fiance Luke plays TD Lane and Bent Hoven. So I've got a motley crew. And we have a bunch of fun. We normally stream every other Wednesday, but we're all adults with crazy schedules, and none of us make money off of the D&D stream. It's all like volunteer, and we encourage people to donate to charities instead of super chatting and stuff like that. So, so it's sometimes it can be hit or miss if our schedules don't allow. Anywho, so that's coming up, and then hopefully I will get a filmed scripted video out. I'm very excited for that. We're almost ready in the Weather 101 series to start talking about what's called a skew T diagram, which is like a vertical profile of the atmosphere. And actually, you can use those to do some really powerful forecasting. They're very powerful forecasting tools, and especially for severe weather. So as we are, oh goodness, we are in severe storm season, especially down in the Southeast. It's definitely a very active tornado season in the US Southeast this year. So pay attention to those. I think I'm also going to do a tornado safety video because I just feel like I need to. Anywho, okay. Mary is saying that never a sweet cereal kid when you were little, cornflakes or wheat flakes with a sprinkle of sugar and some slices of banana. Yeah, that's kind of much more. I was much more likely to have not sugar as my breakfast when I was a kid. That was a thing my mom was sort of against. Oh, Midwest Nerd, I'm so glad you found D&D through us. I found D&D through actual play shows, and kind of fell in love with it because it is a beautiful mix of like my creative brain and my analytic brain. So it's a beautiful mix of like storytelling, but then also there's math and probabilities, and I have to stat out monsters, and that's really fun for me. And it sort of uses all parts of my brain, and it makes me very happy. Okay, that's possibly I've wasted enough time. So we're going to talk about stellar formation theory as it's described by Answers Research Journal. Oh, can I do this? Oh no, that's way too small. I don't like it. Okay. So Answers Research Journal is not an actual research journal, but this is let's go with blog that Answers in Genesis puts out periodically and claims it to be peer-reviewed research. I've done a stream where we looked into like, how does one submit a paper here? And the requirements were kind of laughable. This, I've peeked at it a little bit. It's not so much, so like they're kind of doing the thing that a lot of creation ministries do, which is using one word but meaning something else, right? Which is something that I think is really, really nefarious in a lot of pseudoscience, which is we're going to make up our own terminology so that if you Google, right, stellar formation theory, or you Google chemical evolution, right? That's a great one because that's a term that doesn't exist outside of creationism. That's not the correct term. Then you're only going to get if you Google, say, chemical evolution, you will only get creationist answers because no one else calls it that. So this is not talking about stellar formation theory, again, to the point that I read, because that would be how do stars form? And that matters what type of star you're talking about, right? I do not remember all the technical names and all of there's like different classes of stars, and those are just not technical names I carry around in my head. But the basic idea is that if we're thinking all the way back to the Big Bang, effectively the only element that existed, there was a very little bit of helium, but it was just hydrogen, right? That was all that existed. And so stars that originally formed right after the Big Bang would have been entirely made out of hydrogen. And those guys have pretty different life cycles than later stage stars. It's like our star has a lot of helium, right? It has comparatively a lot of helium to those early stars, and it also has heavier elements. But like our star couldn't have formed until, those early stars went through their full complete life cycle, because how do you get elements heavier than hydrogen and helium? You need a star. They need to be fused together in the heart of a star. And that'll get you all the way up through iron. And then after iron, if you want anything heavier than iron, so an atomic number, anything past iron on your periodic table, awesome in Western. So just category 1, 2, and 3. I think that's it too, but I forget the exact distinctions between those categories. So we'll just speak kind of generally to what these things are. Uh, I'm sorry, I always get distracted when I read the chat, but I love to read the chat. I love to see what you guys are talking about. Okay. So, that's not what this is talking about, as far as I can tell. This is talking about how do stars like our sun form, and also how do solar systems form. And I've linked a resource in the description, which is the class I took in undergrad that taught me this. So that was back when I was at MIT, like a decade ago. And MIT is really wonderful in that they almost all of their courses that are offered at MIT are available for free to the public online through their site Open Course Ware. So I've linked the Open Course Ware class for 12002, which is physics and chemistry of the terrestrial planets. And if I need to, I can grab my textbook from that. It's on my shelf over there. But okay, so let's get into what this journal article is. All right. Dr. Danny Faulkner. I do not know who he is. Maybe we'll check out who he is here in a little bit, but I kind of want to get into this. Okay. Here I review some of the naturalistic theories of how stars form. I discuss many topics never described in the creation literature before. Rather than a critique of those theories, this review is intended to inform fellow creationists what the current thinking about stellar formation is. From the physical standpoint, the conclusion that some star formation may occur today appears unavoidable. So that's great. That's really lovely, because that's definitely a talking point of Kent Hovind and a few other people, and maybe Ken Ham. This feels like something Ken Ham would say, because he's the "Were you there" guy. But that stars aren't forming today is because we don't see them forming today, which is a very silly argument because it takes such a long time for a star to form. So has any human ever observed a star form? No, of course not, because that takes I think several 100 million years. At least tens of millions of years. I might be messed up on my order of magnitude there. But so no human has ever been alive. Humans haven't existed that long. But we can see every stage of stellar formation currently out in space because we can look at different points, right? Okay. So him admitting that stars are forming today is actually, or him saying that hey, creationists, this is a thing we've got to accept, is actually pretty awesome. Oh, hey, Bet. Good to see you. Yeah. Exactly. What's an order of magnitude between friends, especially when we're thinking about astrophysics? Okay. So, okay. Recent creationists appear to be divided on the question of whether stars form today. For instance, this sucker, Thomas, has argued that stars cannot form today because God made all the stars on the fourth day, the fourth of the creation week. We might have to check out that Thomas paper. This is cracking me up that he's citing. You should cite sources, but this is this looks like someone. This looks like a game of pretend to me, if I'm being fully honest. Of we're pretending to write a real journal article. Okay. And then certainly review articles show up in journals all the time. But we'll see if this is written to academics or to the general public. Okay. On the other hand, Faulkner, the guy that wrote this, has argued that God's creation of stars on day 4 does not necessarily preclude the possibility that at least a few stars could form today, any more than the creation of land animals on day 6 prevents new animals from being born today. Besides possible biblical objections to star formation today, recent creationists are divided over physical reasons for doubting star formation. Molfinger, Williams, and Henry argued that stars forming from gas clouds would violate the second law of thermodynamics. Oh no! While Faulkner disagreed. Oh no. Okay. So one of the reasons this feels like plain pretend on a science article is that this sounds like a theological discussion and not a scientific discussion, right? And in fact, this is a theological discussion, not a scientific discussion. But let's talk about why stars forming does not break the second law of thermodynamics. This drives me insane how poorly understood thermodynamics is by all creation apologists. Jeez. Okay. So the second law of thermodynamics. So, okay, let's back up a second and talk about the first law. So, the first law of thermodynamics is a restating of the kind of universal law that energy cannot be created or destroyed. So, the laws of thermodynamics are fundamentally related to how engines work, or anything that you can relate to an engine. So if we're thinking about transfers of energy, transfers of heat, how can we store different forms of heat? So, like, I can relate a hurricane to a steam engine incredibly simply. A hurricane is an incredibly powerful heat engine, and that is just what it is. It just happens to form naturally. So anyway, okay, so the first law of thermodynamics is going to say that so energy can't be created or destroyed. And you can phrase that in a more thermodynamic specific way. I've got a video in the Weather 101 series on it, where I go and I spend like 5 minutes talking about it. But that's all it says, is that I can't get more energy out of an engine than what gets put into the engine. Right? We don't get anything for free. And then the second law of thermodynamics is going to say that the entropy of a closed thermodynamic system always increases. And what that means in plain English is that not only can I not get the same amount of energy, not only can I not get more energy out of an engine than what I put in, I in fact can't even break even. I can't get, if I put energy into a system, the energy that I get out of it will be less than what I put in. So you can't win is the first law, and you can't break even is the second law. But and that's not how creationists talk about the second law of thermodynamics. They get very philosophical about it, and it all has to do with that idea of entropy. I've also got a whole video in the Weather 101 series about just what is entropy, because it's very poorly understood. And like I said, lots of folks, not just creationists, but especially creationists, but lots of folks like to get real philosophical about what entropy is. And it's I don't know. Science doesn't need to get real philosophical, right? And scientists are not philosophers. Like, that's not a field I am trained in, so I'm not gonna try to philosophize. And so I get a little frustrated when people like mix physics and philosophy. It's a pet peeve of mine. Anywho, I'm gonna make my face a little bigger for a second because I'm gonna talk for a minute. So, what entropy is the amount of energy that is in a system that is unavailable to do work. So, for example, you put gas in your car, you turn your car on, your car turns that gas into make the car go vroom, right? And truth is absolutely true. Entropy does stay the same for reversible processes. Yeah, so it's true. Reversible processes are going to be kind of theoretical. Like, in real life, there's no such thing as a fully reversible process. You're going to lose energy on the way in and lose energy on the way out. But for like a physics class or an engineering 101 class, that's absolutely true. And there's some things that it's maybe okay to model as that. But anyway, so you put gas into your car, and then that gas gets turned into power to make your car go forward or backwards, live your life. Um, so, but that's not 100% efficient, right? Some energy is lost because your engine heats up, right? Your engine gets hot. That heat is formed by the engine running. It's formed by friction, right? And that heat isn't making your car go forward. It's not making you go vroom. That's energy that's lost. So if we want to measure that, that would be part of the entropy of that system. Um, so where people and it's kind of as simple as that. So like it's the amount of energy that you lose to like heat, friction, just stuff because as there's no such thing as a 100% efficient engine. They do not exist literally anywhere. However, lots of guys who like to philosophize and pretty much all creation apologists. I forget who it is. There's like one creationist that's like, guys, stop using. I think it's Sal because we stand Sal. He's a chill guy. I think he's like, guys, you can't keep using the law of thermodynamics, second law of thermodynamics like this. That's not what it means. But they'll say that it's the amount of chaos or disorder of a system always increases, right? And so like, and so how that gets us to stellar formation, and this like, how could we possibly have stars forming? Wouldn't that break the second law of thermodynamics? That's taking like a star is a more ordered form than random particles, right? So how could you possibly make a star, right? That's the argument. It's very silly and shows a fundamental lack of understanding of what entropy is. But how do you make a star that way? Gravity, friends. That's what happens. Gravity pulls particles together, and that's it. It's not more complicated than that. It's just gravity. Just gravity. That's it. Right. Um so the idea that like entropy exists certainly doesn't preclude forces from acting on particles, team. And again, I don't like a definition of entropy is like a measure of the amount of disorder of a system. Oh boy, howdy, do I not find that to be a useful definition. It's just not useful. Because again, that feels super philosophical. And I think it's trying to get at the heart of like, but what is entropy? It's an energy. That's all it is. It's an energy. It's energy we're not allowed to use to make this engine go. Anywho, okay, so that's very silly. Okay, this is a very silly argument from Mulfinger, Williams, and Henry. Okay. Why do astronomers generally think that stars form today? Since stars radiate energy, they must possess energy sources. All energy sources are finite, so the lifetime of any star may be estimated by dividing its energy supply by its observed luminosity, which is related to the power of the star. The energy source of stars is generally understood to be nuclear fusion of hydrogen into helium. Oh, so no, I mean, kind of. Let's talk about this. For quantum reasons, it's actually easier to fuse helium. And so, like, our star is generally burning helium right now. Certainly, fusion of hydrogen certainly goes on because stars are still almost entirely hydrogen. But it's a little. I guess this is fine. This is just. So let me back up. I am reading this not like a research article. I am reading this like a pop science article. For a pop science article, that's fine. If you're actually going to talk about stars, right? And what fuel they're using, you would need to be a lot more specific if you were really doing a a review paper of stellar formation. So, okay, cool. So okay, but I guess, like, again, for a general audience, that's an acceptable simplification, but it is more complicated. This energy source is very large, absolutely, but it's not unlimited. The estimated lifetime of the least massive stars greatly exceeds that of the 13.8 billion year age for the Big Bang. So low mass stars could be primordial. That doesn't sound wrong to me. That's not something I can fact check just by information that's already inside my head, but that's okay. However, the lifetimes of the most massive stars are computed to be on the order of a few million years. And again, we'll just take his word for that. I wish there was a citation there, but that's not something I know how to cite off. I can't fact check that up. Those aren't numbers I carry around in my head. I know that our star is 4.5 billion years old. And 4.5 billion years old, and its projected lifetime, we're about halfway through its lifetime. So our star's lifetime is going to be 8 or 9 billion years. So stars have different lifetimes. That's absolutely true. And it's also absolutely true that, like, the most massive stars, so it's kind of the what's that silly little self-help adage? The brighter the flame, like the brighter, I don't know, like the brighter you burn, the quicker you die, or something like that. That's true of stars. Um so yeah, like the brighter, more powerful, more stuff, if they're burning everything really fast, it's not going to live as long, but while it does live, it is really bright, high luminosity, pumping out a lot of power. Okay, cool. Therefore, in a Big Bang universe, the most massive stars must have formed very recently. Even a mid-range star like the Sun cannot be primordial. The Sun's maximum lifetime is nearly 10 billion. But also, we also know that our Sun, right? Our Sun could not have formed out of the Big Bang, because we know, by some very clever astronomers and very precise measurements, that there are heavier elements inside of our Sun than just hydrogen and helium, right? Our Sun could not have been primordial, not only because of the lifetime, but because of its composition. So there's more things to this. So it's not just time. Therefore, in the evolutionary model, there's a need for ongoing star formation. So this is a bad sentence. I don't like this sentence. So one, evolution just refers to biology and literally nothing else, right? So in this current evolutionary model, that's just, we're not calling a thing by its name. We're making up words for no good reason. And there's a need for ongoing star formation. That's also very deceptive phrasing, and I'm not a fan. Reason I'm not a fan. Okay, great. We'll do a Highlander quote. It's better to burn out than fade away. Love it. And also, welcome, Dora. We see you. Glad you're here. Okay. So that's really bad phrasing, because it is not that we have a preconceived notion of how the universe functions and fit other things to it, right? That is not what we do, right? That's not how science works. That's how creation science works, but that is not how actual science works, right? Actual science looks to we look to what our observations tell us and then draw conclusions from there. So our observations tell us, we have lots of observations and measurements that's going to date our sun at 4.5-ish, 4.5, 4.6 billion years old. And that's going to be true. And we also have, and we can, again, through some very careful measurements and understanding about like brightness of the sun and things like this. Uh, but I'm not an astronomer, so I don't know all the details of that. Anywho, not off the top of my head. And this is a cozy live stream where I'm in my favorite unicorn hoodie. I hope you guys are too. Anywho. Oh, and there's definitely some points in the chat here. So one from Mary, all Yeckers claim evolution is all of them from the Big Bang to abiogenesis to actual evolution. And then Caleb is saying 6 types of evolution, Kenthoven and literally nobody else, right? So yeah, this is again an example of how this is a form of information control that's come from the BITE model for like how can you tell if something is a cult, right? So the way this is a form of information control and how the cult, which I'm going to put a big umbrella of creationism and young earth creationism under an umbrella of a cult, because they're controlling the information that their like members are able to access by using cult specific language, right? So again, if we Google chemical evolution or something like that, will only get creationist sources. So in some cults, like Scientology, members are like punished if they or not allowed to look at any sources not made by the organization, right? Don't Google it, et cetera, so forth. I think young earth creationism is a little like it's kind of nefarious, right? But it's also like smart, it was, and that they recognize there's no central control. Oh no, there's no one person in charge of all young earth creationism, right? It's more modular. And so no one's going to be able to control or monitor every single young earth creationist's like Google search history. That's not going to happen. So what they do instead is use this cult specific language to ensure that their members are unequipped to do their own research. And so when they do try to research this and learn more, it only reinforces the cult belief because they're getting only creationist sources, because they're using this cult specific made up vocabulary that nobody else uses. Okay. Okay. So this sentence, therefore, in the current evolutionary model, there is a need for ongoing star formation. No, my friend. We just point our telescopes out at the sky and observe stars forming, right? There's no like, oh, by golly, stars better be forming, or everything we know about the universe is wrong. No, it's like we looked and stars are forming, therefore we say that stars are forming. That's it, full stop. There's none of this like need. And it just so happens that all of these data points together, the like age of our star, the known of what type of category different stars are, astronomy evidence where we can point our telescopes and see stellar formation, universal background radiation telling us about the age of the universe. All of these things point to the same answer. And so we can say with a high degree of confidence, so it looks like the Big Bang happened this time ago, and these are all the consequences and fallout of it, right? It's not that we decided that was true and then cherry-picked evidence to see it. No. It's through several independent methods of inquiry. Lots of different fields all support the same conclusion, making that a very robust conclusion. Okay. Cool. All right. Okay. Where might stars form? The space between stars is not empty. The interstellar medium contains very rarefied yet significant amount of matter. So that is true, right? I think like the definition of a vacuum in space is a vacuum. There's like a theoretical vacuum, which is literally nothing. And then there's in reality, there's particles flying around space all the time. So you look at like there's less than X number of particles like per volume. And so it's very, very, very small. If you go out into empty space, there's almost nothing, but there are still stray particles. And then this interstellar medium is not uniform, so that's true. It's very clumpy, right? So the amount of material in a galaxy is a lot more than the amount of material between two galaxies. Certainly true. With wide variations in density, while the typical interstellar medium may have an average number of density less than 1 particle per cubic centimeter, there are clouds in the ISM with number density more than 1,000. Yeah, so particles left to their own devices will clump together under gravity unless other significant forces are acting on them. Cool. Yep. Composition of this, it's mostly hydrogen and helium. Mostly hydrogen. It's still like 99% hydrogen. And then a few percent being heavier elements. Yeah, but did you guys know that this always blows my mind because I am made of mostly carbon, right? I guess I'm made of mostly water, which is lots of hydrogen. But the universe is still 99% hydrogen, and yet you and I and rocks exist, and I think that's really cool to think about. Okay, the masses of large clouds can be many thousands of solar masses. Sure can. Given that gas clouds have a composition similar to stars and sufficient mass, astronomers generally conclude that under the right conditions, gas clouds can collapse to form stars. Yes, this would be a protostar where you just have like a collection of gases and everything. It's hot enough, right, that everything's going to be in a gaseous form, even like iron. So Dora, I'm gonna take this ugly bags of mostly water. Water. I can't do a Kent Hovind voice, and I don't want to spoil my morning by trying that. Yeah, ugly bags of mostly water with anxiety. That's how I'm gonna define humans. Anywho, cool. How gas clouds make collapse to form stars is so generally what you get is you're going to think about like you get a nebula, right? So we're going to get a collection of gases, and under the right conditions these will continue to kind of collapse in on itself until fusion starts, and we get this like we start to get a star. It would be a protostar at that point. And then any of those gases that weren't, so once you have a protostar, you'll start to get what's called a protoplanetary disk. So you'll have a effectively two-dimensional disk of gas that orbits around this protostar. And again, under the right conditions, those gases will start to coalesce, form larger and larger molecules. Believe it or not, the protostar is hotter than a regular star. So as the protostar forms, we're going to start to cool. As the protostar becomes a star, we'll start to cool. And then as we start to cool, we'll see out of this protoplanetary disk, different elements and compounds will start to precipitate out. So they'll start to solidify. What's really, really, really cool is that the elements that are going to first condense out of this gaseous cloud and form solids and start to accrete, mostly under gravity. At first, it's like Brownian motion, and then it starts to be gravity as they get big enough to smash into each other. The first things that are going to come out are going to be rocks. Okay, so why are the inner planets of our solar system rocky? Because those are the first elements that are able to precipitate out of the protoplanetary disk. because those have like the highest point where they're going to solidify, the highest temperature where they're going to solidify. And then as we move further away from that protoplanetary disk, and so what's going to precipitate out later, when it's a little cooler, well, that's where we're going to start to get our like the hydrogen and helium compounds that make up our gas giants, Jupiter and Saturn. And then we'll get some of the ices, like methane ice and things like that, that make up Uranus and Neptune, things like that. So it's really cool. You can kind of see the progression. It turns out the composition of the planets in our solar system exactly matches. Exactly matches the order in which elements and compounds should precipitate out of this protoplanetary disk. It's really, 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 really cool. Okay, so let's jump back to this. How gas clouds may collapse to form stars is not entirely understood. That's true. Like we definitely have a lot of good working theories, a good like working understanding. But some of the processes are unknown. And this sentence bothers me a lot. One can find frank admission of the physical problems with star formation in the astronomical literature, often in advanced textbooks on stellar structure. And we should just leave out this and evolution, because that's not, if a textbook on evolution starts talking about star formation, I'm going to be very upset. But they had to toss the buzzword in, didn't they? Okay. So, this frank admission, that's what drives me nuts. Because to me, this shows a pretty frank lack of understanding. A pretty frank lack of understanding of how science works, right? And that I think is something that I've noticed. Like the more I look at young Earth creationism and like talk to young Earth creationists and try to understand their mindset, they really don't like the idea of the phrase "I don't know" or "we don't know yet," right? Whereas for me as a scientist, that's what's exciting, right? How boring would it be if we fully understood how literally everything worked? One, I would be out of a job, right? I don't have a job if there aren't open questions in science. And so open questions aren't bad things. Open questions are great and fun. Science isn't memorizing a list of facts. It's the exploration of the unknown. And so this frank admission, that phrase really bothers me, but I think it highlights the mindset of young Earth creationists, which is, nope, everything that needs to be known is already known and perfectly prescribed, and science is just memorizing facts, right? And how boring is that? Two, I think this also comes from, if we're thinking about high demand religions and cults, questioning is discouraged, right? Sometimes actively punished. And so, of course, all of the answers already exist, right? Because if they didn't, I would have to ask questions. I would have to figure things out on my own, and we can't possibly have that in that high demand religion. And so I think that attitude and that mindset transfers over to a lot of their mindsets towards science. Note that that is not that type of thinking of nope, we definitely can't ask questions. That's not a thing we ever do ever. I don't think that's so. One, that's not indicative of all religions. I would say that's a thing that's indicative of toxic religions, right? And toxic religious practices. Um, uh, yeah, Caleb, but the Bible tells us don't cook a baby goat in its mother's milk. That's a very important rule. um, and so, it's important to remember, and I think I've said this in every single one of my live streams, that the majority of people of faith fully accept conventional science, right? And the majority of scientists are people of faith, myself included. And not being allowed to question faith is absolutely a sign of a cult, and you should not go to that. You should avoid that location, right? And those people, for your own safety and well-being. And so certainly if we didn't question things in science, then we wouldn't do science, right? Then it wouldn't exist. So this, like, the fact that there's physical problems with star formation, that just, there's things we don't understand yet. That doesn't mean the pieces that we do understand are wrong. It's just we haven't worked out all the details because there's open questions in science. There's always open questions. Again, if there weren't, we'd be done with science. We would have reached the end of the internet. Anyhow, all right. But this type of vocabulary is really common with young Earth creationists. Of, see, even secular scientists admit that abiogenesis is a problem. It's like, no, we don't understand how abiogenesis works. Like, we don't fully understand how stars form, right? Because I can't make one in a lab, right? No humans haven't been around long enough to have fully watched this process happen, right? So we've got a lot of theories, things that have evidence, and a good responsible scientist, when they're presenting a theory or their ideas, will also present the problems with it. Because I'm not fully right, right? I am contributing to the effort of being less wrong. And that's what science is. Okay. I'll end that rant. However, simply quoting such sources falls short of an effective response to the theory of star formation. No shit, Sherlock. Because it's not an admission. It's not like an admission. It's not this big, crazy thing. It's just, this is what we know. This is what we don't know. By the way, people saying that bluntly is very helpful for grad students looking for dissertation topics. Just saying. Okay, there are many examples of physical processes not being fully understood. Thank you, author of this paper. For instance, there is much we don't understand about the formation of storm-related phenomena, such as lightning, tornadoes, and hurricanes. Absolutely. But gaps in our knowledge of such things are hardly good arguments against the reality of them. There you go. Okay. Wow, we're not going to talk about science from 1734. We're just going to skip all over this. The Nebular Hypothesis is more concerned with the formation of a disk around a young sun, which the planets supposedly form. That's actually still the working, like, that's what I just described. You have the protoplanetary disk and all of that. That is real. Like, that's still the best understanding of how these things form. Cool. What is the genes criterion? I know what I'm thinking of. There's a thing called genes escape, which is how planetary atmospheres form, and what elements are going to escape out to space. But I don't actually know what the genes criterion is. Okay. Sir James Jeans is associated with the theory of star formation more than any other single individual. He was the first to derive a physical description of what process star formation from a gas cloud might entail. Hey, look, the change in pressure with respect to radius is going to be negative the gravitational constant. The mass of the cloud is a function of radius times the density of the cloud over the radius squared. That's absolutely going to be its gravitational collapse and getting to yeah. So if left unopposed, so we get it's collapsing under gravity. There are other forces that oppose it. For example, electrostatic forces start to be a problem when we're trying to really, really compact things together. Cool. So if the only two forces, so the hydrostatic force or hydrostatic balance, so pressure and gravity, if these are the only two forces at work, then even the slight imbalance in favor of gravity ought to overcome the constraint of hydrostatic equilibrium and lead to the gradual collapse of a gas cloud into a star. Cool. This is all he's saying here is this is an overly simplified explanation. Of course it is. Um, it's like a perfect mathematical equation for it, right? That was developed in 1902. Nothing, no shade on that work. But if you're going to have like beautiful math equations for physical processes, you've generally got to make some assumptions and simplify things down. Okay. Now, generally, you have to justify those assumptions, right? So they need to be good assumptions, but they are always hiding some detail, even if it's a good representation. Okay. Okay, so assume a very large cloud with the gas initially at rest and having uniform density, pressure, and temperature, and having gravitational potential phi. There are two fluid dynamics equations that apply. The first is the continuity equation. Yeah, this is all this equation says is that mass is conserved. Once we get into fusion, that's not true anymore. Is this guy the meteorologist? Because these are all meteorology equations. I mean, I know these are like fluid dynamics equations, but these are in the forms I am used to seeing. Let's find out. Let's find out. And this is conservation of momentum. Lovely. Okay. Sorry, who is this? Who is this dude? And I switched tabs, but you guys can't see that. So let me switch what screen I'm sharing. Oh, hey, Dapper. Okay, sorry. I got distracted by chat. I'm gonna change which screen I'm sharing. So I'm gonna do this, and then I'm gonna do this. Chrome tab. This dude. Share. He has a master's degree in physics from Clemson and a master's of the arts and PhD in astronomy from Indiana and taught at the University of South Carolina, Lancaster. He is now works as a researcher, author, and speaker for Answers in Genesis. Okay, so I guess he's not. Sorry, I thought this one of the creation scientists that gets toted out a lot is a meteorologist. And I couldn't remember who it was. But again, like I said, I was like, these are all the forms of these fluid dynamics equations that I am used to seeing. So I was sus that it might have been him, but it's not. So he's apparently trained as an astronomer. So that's cool. I mean, to me, that also means he should know better. And he absolutely knows that this is not a review article. This is pop science. So yeah. All right. Am I on? No, this one. We're on the right thing now. Okay. So he's just explaining, this is just the fluid dynamics of how you would get this collapse under gravity. We don't need to go through all of the math of that. Like if you guys want me to do that, I'll do a proper like explanation series video on like this is how stars and planets form. We're not gonna go through this super detailed. Okay. I will say this. This is written as a pop science article. This is written to a non-specialist audience. This isn't how I write or speak or communicate to a non-specialist audience. Yeah, Dapper, get your coffee. I've got mine. Anywho, these are partial differential equations, right? I'm gonna sneeze. You guys should be very glad I muted. That was very loud. Anywho, okay, like I'm going to give a broad overview of how these things work to a general audience, right? And that's what I thought this article was. But now we're into, I'm going to teach you guys some math, which I think that's a different audience, right? Um, if you're doing, in my opinion, like pop science or science communication in general, should be done at about like an eighth grade level. Um, because like that's what newspapers are written to. That's not a bad level to write at. That's kind of a rule of thumb for our society's presumed level of general knowledge, right? So for example, I'm going to assume if I'm talking about like atoms, I'm going to assume everybody knows that atoms have a nucleus. Inside that nucleus are protons and neutrons, and orbiting them are electrons, and that like chemistry happens when two different atoms meet and their electrons become friends, right? That's the level of understanding I'm going to expect the general public to have about chemistry. So if I need to talk about anything more complicated than that, I need to explain it carefully. That doesn't involve PDEs, right? Now, if I was going to like teach a class, and you could put that on a forum like YouTube, right? About fluid dynamics, we would have to get into some PDEs. But that changes from like general science communication to the general public to I'm going to like teach a specific thing. And he seems to be fusing those together, which is just I can't help but sometimes I think people throw in equations into pop science stuff, or like creationists do this to like look look at this complicated looking equation that I'm not going to explain to you what it means. Doesn't that make me seem really smart? And that's not helpful to other people's understanding, right? You're not here to show off, you're here to communicate clearly. Um yeah, like trying to impress. Thank you, truth nerds, for continuously summarizing my rambles into one-liners. I appreciate you. Loop. Okay. Okay, so we're gonna go back to this view. We're gonna get through all their PDEs, and uh my goodness, we're taking determinants of matrices. Yeah, no one, your audience does not know what this means, my guy. Okay. So, if the mass of a gas cloud having temperature T naught and density rho naught exceeds the gene's mass, this would be the gene's mass, then it is unstable and ought to collapse due to its own gravity. That was, goodness gracious, all of that to get to this. And so that's like, I think I remember maybe being taught that I didn't take an astronomy class. I took like a couple planetary science classes. And so I don't remember if we learned this. So we talked a lot more about planetary formation than we did stellar formation. Okay. But that's okay. Like this, none about this seems wrong. But that's okay. Before proceeding, I must address the concerns about the simplifying assumptions. Of course, gas clouds are not isothermal. They don't have uniform density. Again, that's because Jean came up with this criterion in 1902, right? If he was going to make any reasonable progress, he needed to make those assumptions because he didn't have a computer model to allow for temperature fluctuations and things like that. So those are certainly, like, it is important to note that there's limitations of like perfect mathematical models. But those are going to be the models that's our starting point. And then we're going to add in the complexity as we've developed newer technology and mathematical techniques. The mathematical assumption is that the cloud is infinite, not merely very large. That's a general thing we assume. A lot of times, if we want to say that, like, okay, if I'm here versus here, these 2 points are infinitely far away, such that the gravity isn't acting between them. Because theoretically, by the math, gravity is always acting between 2 points. But in reality, there's a point where it becomes negligible. So we say arbitrarily far away, stuff like this. Epsilon is greater than. I am super glad you're here. I'm glad you're in chat. Hooray. Okay. Okay. Um, So as long as the density and temperature of a cloud do not vary over a wide range, which is what we observed, then these assumptions of uniform density and temperature is not a great departure from the truth of clouds. The departure of a very large but finite cloud does not radically depart from an infinite cloud. Exactly. Okay. So again, this is math that was developed in 1902. This isn't the whole story of what's used today. Uh, cool. We're gonna Here we go. Here's a good sentence. So with all those caveats, he said, there's confidence that the gene's mass is well within an order of magnitude of being realistic. And in astronomy, and also one of my favorite things to say, what's an order of magnitude between friends? So, but by that order of magnitude, he means like, okay, so if it's 10, right? The real number might be 12 or 20 or 50, but it's not 1 and it's not 100, right? It's And often in astronomy and in other things, we're going to think about order of magnitude stuff. And exactly, what is an order of magnitude between friends? Robert, you're confirming that I didn't make that term up. It's just one of my favorite science jokes. Um, okay. Excellent. All right, let's keep going. Let's see if we get. Oh, good. A reviewer recommended including a simpler, less rigorous derivation of the genes criterion. We're also going to skip over this because what we cared about there was the conclusion. We're not in an astronomy class. We're doing some Sunday morning science. Drinking our coffee. Cool, 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 cool. There we go. More math. That's fine. Great. No. Okay. Do. Okay. Okay, here we go. What causes instability? So we have a cloud and it has the potential to turn into a star, but it needs some type of triggering event. The collapse of a cloud to form a star takes more than a few thousand years. For most stars, this process requires millions of years, far less than the supposed 10 plus billion year age of the universe. Friend, that's a non sequitur. That is a nonsense sentence. Oh, I'm so sorry. I was hiding my screen. You guys can't see what I'm seeing. There, I fixed it. You can see it now. Okay. Okay. Yeah, Robert, we probably did. Okay. So this I don't even know what he's trying to say by this, other than like, see, stars can form in less time than the universe is old, but it still takes 10 like it's millions of years for a universe that you're going to say is 6,000 years old. That doesn't make any sense. And like, so what is he trying to say? Sorry, this is hard for me. I'm trying to understand what point he is trying to get across with this sentence. And that's kind of hard because we're not I've got to put myself into like the creationist mindset for a second of like, what do I think is true? What do they think is true? What do they think problems with conventional science are? And I'm really having trouble with this because like stars are currently forming. That's the like and stars have formed at different points during the lifetime of our universe. That is, in a nutshell, conventional science, right? So we should hope that it takes less time to form a star than the age of the universe. Because if those two numbers were discordant, then we wouldn't have any stars. So I don't know what he's trying to say, and I think I'm gonna hurt my brain if I think about it much more. Okay, we'll move on. Okay. If the cores of molecular clouds are prone to collapse, it's obvious that they could not have existed in their current state very long, only for a few tens of millions of years at most. Oh, okay. I should have read the next sentence. That's he's saying that uh under conventional science and conventional timelines, of course, stars are now forming. Not all like nebulas, not all protostars could have formed at the Big Bang. Yeah, dude, of course. Okay. In a recent creation model, oh no, this is not a difficulty. Okay. In a recent creation model, not a model of how the universe formed recently made by creationists, but in the universe is 6,000 years old. We're not even going to dignify that by calling it a model, but in that mindset, this is not a difficulty. God could have created gas clouds in the process of collapse. Appeal to magic, right? Appeal to magic. This is that's not a real like logical fallacy. That's just one of my favorite things to say. Like, well, if God's omnipotent, then he could have done it. It's like, well, that's not helpful. Like, that's not helpful to understanding how the universe functions, right? Because all we've got is what we can see and observe, right? With different tools. We don't have to see it with our own eyes, but anyhow. Okay. However, if the universe is billions of years old, how did molecular clouds form? Under gravity. I don't uh uh okay. So this is like, if God didn't do it, how could it possibly have happened? Since much of the interstellar medium outside of whatever that is, the stuff between stars, outside of molecular clouds is not prone to collapse. Star formation needs some mechanism to initiate the process. There have been several suggested triggers for star formation. The most popular mechanism is supernova explosions. Supernova eject considerable matter at high speeds, as great as 10% the speed of light. These speeds are hypersonic. No joke, man. Okay. So faster than the speed of sound through the medium. Like, no shit, Sherlock. So the expanding matter overtakes that the kind of background matter along a shock front that compresses and heats that matter. Sorry, I've forgotten what ISM stands for because that was way back. Yeah. Okay. Along a shock front that compresses and heats the material. This interaction slows the shock front, but the expanding front of material can travel tens of parsecs before ceasing to be hypersonic. Since the restoring force of pressure acts at the speed of sound, a shock front easily overwhelms the force acting to resist the compression of gas. Astronomers believe this compression acts to produce clouds that meet the Jeans criterion for gravitational contraction, leading to star formation. Cool. So that's an answer. That's a possibility. Another proposed trigger is dust. We have two primary components, gas and dust. Gas is made of atoms, ions, and molecules. Dust is made of solid particles encompassing many molecules. So dust particles are larger than gas particles. The composition of dust is silicate, ices, and even elemental iron. So think of like, dust is a solid, like itty bitty bits of leftover solar systems. By the way, I don't know if he's going to bring this up, but like, you only get dust if you've already had a star go supernova. Right? Because you can only get iron out there or bits of rock if you've already had the star make those elements and then go supernova and spread those elements out into the universe. Due to collisions with gas particles, dust particles are in thermal equilibrium with the surrounding gas. However, unlike gas, dust readily uses heat via emission of infrared radiation. Sure. Cool gas particles are transparent to infrared, so heat radiated by the dust particles is lost. As the dust particles become slightly cooler than the ambient gas, collisions transfer heat from the gas particles to the dust, which is further radiated. Since collisions act to maintain the thermal equilibrium between the dust and gas particles, this process acts as a refrigerator, gradually cooling the gas. Cooler gas produces less pressure, so the cloud contracts due to hydrostatic equilibrium. As this process continues, the density of the gas slowly increases. However, due to loss of internal energy via thermal emission, the temperature of the gas does not change appreciably. Therefore, according to the last equation, the gene's mass will decrease as the density increases. Consequently, this mechanism can shrink a cloud until the inward force of gravity exceeds the outward force of pressure, and the gravity becomes the primary factor driving contraction. Cool. A third proposed trigger is spiral density waves. This was proposed in the 60s. A spiral density wave theory is a solution to the problem of wind-up spiral arms of galaxies. According to the model, spiral arms are maintained by a density enhancement, a sound wave that travels through a spiral galaxy's disk. Being a mechanical wave, the density enhancement travels at a velocity entirely independent of orbital velocity due to gravity. However, gravity does modify the wave, as does the varying density of the ISM. As a sound wave passes through the ISM, gas clouds are compressed to reach the Jeans criterion, whereupon, so another version of basically the sound wave shock wave kind of thing. It's just formed from a different trigger. I'm gonna skim. Is there supporting evidence for this? Massive blue stars are formed along spiral arms. These stars have very short lifetimes, and they could not have traveled far since their formation, which explains I love this in the evolutionary model. It just explains it. Why massive blue stars are found along spiral arms, sites of ongoing star formation. Okay, so basically all he said, right, is that there's kind of three leading theories, or three leading theories for how you can get a dense enough cloud to get a protostar. And I don't think those are necessarily mutually exclusive, right? You could have like all three could be true, right? You don't need just one mechanism. Same way, think about it, like earthquakes can be formed by different types of motion of plate tectonics, right? Like we know what we need is for plates to move, and that's going to generate an earthquake. But like you can have a strike slip fault, you can have like subduction zone, there's different ways to get them. There can be a different way to skin a cat. More than one way to skin a cat. By the way, is that phrase more than one way to skin a cat? Like, okay. I was perusing Reddit like a sane human, and I got to one of those like, what are your like red flags in interviews for like applying for a job or whatever. And one of the person on there said that like when their interviewer said the phrase more than one way to skin a cat, that like freaked them out to the point that they left the job interview. And I'm like, dude, that's just a common phrase. Like there's more than one way to do things. There's more than one way to skin a cat. I never thought of that as like particularly violent. Even when I was really little and like my mom was like to the point that my mother had to help me get dressed. If she wanted me to like, if we were going to take my shirt off over my head, right? That's what we were going to do. She would say the phrase skin a rabbit when we were doing that. So I don't know, maybe that's just like coming from a more rural area. In Oklahoma, right? Everyone's parents grew up on farms. I don't know. Okay. I was just like, wait, that's just a normal phrase I use in everyday conversation all the time. And am I freaking people out left, right, and center? Anywho, I hope not. I hope my fun colloquialisms are endearing and not terrifying. Okay, sorry. Yeah, so there's potentially more than one way for us to like trigger a star formation event. Cool, it can happen. Um, uh, yes, and absolutely. He's gonna go say before moving on, it's important to remember that like most, if not all, proposed triggers for star formation require that stars first exist. So this is kind of like the process by which stars form now is different than the process by which the first stars out of the Big Bang formed. Um, and these are different things. Yeah, these are different things. So this isn't like those three theories he just described are these are ideas for how we propose stars form now, which is not the same as theories of how stars formed right after the Big Bang, right? How the first stars formed. Different things. For instance, yeah, supernova is an explosion of stars. You wouldn't have dust before stars. Absolutely. Um, it was. Uh, sorry, he's just explaining that, like, that he's explaining and like showing this as a problem that these mechanisms don't explain how the first stars form. That's true. I don't. Okay. Um. Do do do. So the ultimate cause of star formation remains a mystery. Like, no, I think that's a little That's a misleading phrasing. Um. Uh. That's a misleading phrasing to me because, like, um, I'm trying to. I don't know. I was trying to come up with an analogy, but like, there's more stuff in space now than there was right after the Big Bang. Therefore, the way stuff in space interacts is different now than it was right after the Big Bang. These are different scenarios, like, storms on Jupiter are very different than storms on Earth. They're following the same basic principles, right? Following the same fluid mechanics, but Jupiter rotates faster. There's little to no friction. So storms like the Great Red Spot last for as long as we've been able to look at Jupiter, right? Galileo looked at the same storm you and I can look at. Storms on planet Earth don't last that long because there are other factors at play, right? So different conditions leading to different way things interact being different isn't a problem. But he seems to be proposing that that we need one theory of stellar formation, not, well, stars can form in multiple ways today. Here's some possibilities. Maybe it really is only one, or maybe it's all three. Maybe all three happen at different places. But these mechanisms don't help us get the first stars. The first stars have to be explained by a different mechanism. That's it. That's all. That all sounds like unwelcome nuance, Staffer. Yeah. 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 Okay. Okay. Cool. Protostars. As previously pointed out, astronomers consider molecular clouds to be likely sites of star formation. With such large masses, astronomers do not think that molecular clouds collapse to form single stars. Rather, astronomers think the densest inner parts collapse first, with infall of surrounding material upon them. Thus, large clouds typically would sub-fragment to produce mini-stars. The physical reason for this is that as density rises, the gene's mass decreases, so individual subclouds become super. genes and start their own collapse. This is believed to be the mechanism whereby star clusters form. That's certainly true. If you take your telescope and you point it to any point in the sky, you're going to see that stars are not uniformly distributed, right? They'll be like, oh, we've got a bunch here and none over there. So why would that be? Here is why. The cores of collapsing stars are thought to be denser than average, having number densities of many thousands. Cool. Oh, the cores of collapsing stars. Sorry, I assumed he was talking about dying stars, like supernova. I think he's talking about like the collapsing molecular clouds to form a star. Because included dust scatters visible light, the collapsing cores ought to appear darker when not totally embedded in molecular clouds. When silhouetted against bright backgrounds, these cores would stand out. Yep, so you can point your telescope at things and see them, which is really cool. Yeah, I love this. That's like, we made a prediction that like, oh, okay, because of these like thermodynamic properties, right? And we know that we know, right, that temperature of a body relates to how much like light it's emitting. That's its black body radiation. There is a video on on what black body radiation is. It's in my climate dynamics series. Anywho, so that understanding black body radiation tells astronomers like how bright something should be. And so, hey, we know if we're looking for this like dark spot, that should be evidence of a nebula. And lo and behold, we pointed a telescope at it and we found it. Cool. Cool. That's a picture of a nebula. It's very pretty. This is stellar luminosity as a function of temperature that's related to black body radiation. Sorry, I know I'm kind of like scanning this. Oh, good. For a discussion of the HR diagram in the creation literature, why would that be different? Why would luminosity and temperature be different? That's just like how bright something is related to how hot it is. That's very easily understood from first principles. Okay. We might actually have to read that paper because why would that be different? Okay, because of the enshrouding molecular clouds in which stars presumably form. God, sorry, his manipulative language. I'm going to point it out every single time I see it, right? Because he's like, oh, when there were these presumably form. It's so, God, yeah. Anyway, sorry. I'm just like, I'm going to point it out because so much of creation apologetics isn't science. It's not real arguments. It is manipulative language. Anywho. Okay. I'm getting a little fired up. I need to calm down a bit. Okay. It would be difficult to observe the very earliest stages of star formation since the surface temperature of protostars in their earliest stages would be quite low. They would not be visible to our eyes. True, but we could look for them with other types of telescopes like infrared. Hey, sorry, I hadn't even read this sentence. With such low, they would be quite luminous in the infrared. With such low surface temperature, protostars would be far right on this diagram. Cool. So we can still see them as long as we have the right tool. Then as the protostar is collapsing on itself, right, density is going up, which means heat's going up, which means its luminosity is going up, which means it's easier to see with a telescope. Cool. Then we go from that protostar phase to the pre-main sequence phase. Much of the theory of the pre-main sequence phase of stars having less than 3 solar masses was worked out in the early 60s. I've yet to see a paper, a non-creationist paper from before 1970 cited in this. Hayashi Trex depends on the mass of the forming stars. Cool. Yep, this is still just stuff. This is still just luminosity and all that. An important factor in stellar structure and any consequent change or evolution is gross properties of stars expressed on this luminosity versus temperature diagram is the method of energy transfer from the star's interior to its surface. In most stars, Conduction, yeah, no joke, conduction is a relatively minor method of energy transfer. That leaves radiation and convection. Yep, as a primary means of energy transfer. The most efficient factor in determining which of these two methods of energy transport is predominant is opacity, the measure of how impenetrable to radiation the star's interior is. Opacity is a function of composition, density, and temperature. If the temperature gradient and opacity of stellar envelope will permit effective radiation transfer of heat, then the envelope is said to be radiative. Otherwise, the envelope is convective. The envelope of massive stars are fully radiative, but the envelopes of lower mass stars tend to be dominated by convection. Mid-range stars, such as the sun, have radiative lower envelopes, but convective outer envelopes. Okay, it's cool. So there's three forms of heat transfer, right? Conduction, convection, and radiation. Radiation is the least efficient of the three. And this is going to be like, how are we, like, you have to physically move heat. I know that might seem counterintuitive, right? Because you're like, what are you talking about? When I turn on my space heater and I stand a little bit far away, I just get warm. Yeah, cool, absolutely. However, temperature is a measure of the average random kinetic energy of the particles in a system, right? So you are able to feel the heat from your space heater because physical particles with lots of energy are hitting you, right? That's how we experience heat. Yeah, Mary, that would be so fun. So I can take a break from constant reading of the stupid if I had like a co-host. That would be lovely. I sometimes get co-hosts for these, but not always. It just depends on people's availability. And I'm usually doing video reacts, but I was kind of intrigued by looking at a paper this time. Okay. So if you want to move heat around a star, like, you're going to physically move particles that have different amounts of energy, right? And that amount of energy is related to that amount of heat, right? It's just these two things go together. Okay. And radiation is the exception. So you're still like moving particles, but you're moving like photons, right? So radiation is the least efficient form of heat transfer, and it's going to be by like because it's the only way you can transfer heat through a vacuum. So radiation is how, all stars are going to heat planets around them, right? Because they're emitting electromagnetic radiation that has some energy. When those photons interact like with you and me, when we go stand outside in the sun, right, photons from the sun are interacting with our skin, heats our skin up because those photons are depositing energy. So it's still like moving a particle, I guess. It's just a very specific particle, and that it's photons. Because photons don't have mass, and et cetera, so forth, but they are going to be the only kind of thing that's going to be able to transfer energy through a vacuum or a relative vacuum. Okay, cool. So basically, really massive stars, they're like held together super well, and so only radiation is going to be what like escapes past like a certain, so like the stellar envelope is still part of the star, right? But yeah, sorry, now I'm not quite sure what he was saying because I got distracted. Okay. But I think he's basically just saying that different processes occur in different mass size of stars. So let's go with that. We're gonna just keep scanning through this. So low and this is like lifetime of stars. So low and intermediate mass stars. Gosh, I love this. Are thought to evolve away. Do you like how they like young Earth creationists like to toss the word evolve in just like all the time? Low and intermediate mass stars are thought to evolve away from the main sequence at the end of their main sequence lifetimes to become red giants along paths that are similar to this Hayashi track, except in reverse. So yeah, different stars, there's different life paths stars can take, and it has a lot to do with their mass. Okay, cool. So let's read. We've got a question from creationists here. Therefore, West, 1981, raised the question in the creation literature, we got to put that in quotes every time, whether one can tell if a star is pre-main sequence or post-main sequence. Astronomers generally believe that they can tell the difference between pre-main sequence and post-main sequence stars from the environments that the stars above the main sequence are found. For example, West discussed that binary stars in which one member was on the main sequence and the other star was above the main sequence. And he suggested that the stars of these systems might be very young pre-main sequence stars. Without mentioning them by name, West discussed algol-type binary stars. There are good reasons. So, okay, this is fun. But can we really tell the difference between these? And so therefore, couldn't these stars be really young? And real astronomers are like, no, we can absolutely tell the difference. It's fine. And then the creationists are like, but what if we can't? It's like, but we can. But what if not? Right? And just using a lot of technical language to conceal that they're just like pretending answers to these questions don't already exist. Anyhow, I'm gonna keep looking for creationist claims in this. Wait, what does this mean? Forming stars are expected to be chaotic. Some periodicities may be coincident with heavy spotting that rotate into and out of view. The rotation periods of T-Tauri stars are a few days. Okay, never mind. I thought he was going to get into like thermodynamic, like poorly understanding thermodynamics again, even though he clearly understands thermodynamics. Okay. Ooh, this looks like fun. A major problem with star formation is conservation of angular momentum. Okay, fun. How is that a problem, friend? Virtually all surrounding astronomical bodies possess angular momentum. In the case of gas clouds that might collapse to form stars, the angular momentum could originate from slightly different orbital motion around the galaxy. As a rotating body contracts in size with no external torque acting, angular momentum must be conserved. True. Considering the very large change in size a contracting gas cloud must undergo to form a star, angular momentum conservation presents a difficulty. Poor K. The protostar eventually reaches a point where it is spinning so quickly that further contraction is not possible. Therefore, if stars form this way, there must be a torque acting to remove angular momentum. Okay, astronomers think that magnetic interactions provide this torque. Cool. Okay, so there was a problem and we came up with a solution. So the electromagnetic force is absolutely acting in these clouds, right? Because think about it, we have charged particles, right? Not even just charged particles, but like helium. Not good. Goodness gracious, Maddie, get yourself together. I'm going to take a drink of water and try that again. Okay. When we say hydrogen, you are probably thinking to yourself, a proton, a neutron, and one orbiting electron. That's not how hydrogen appears in the wild most of the time. In the wild, hydrogen appears as a lone rogue proton, right? So when we say hydrogen, and when astronomers and astrophysicists say hydrogen, they mean rogue protons. Protons have a positive charge, a +1, charge. So there's a balance between what's going on here we're collapsing under gravity. Let's say we're just collapsing hydrogen under gravity, right? But now, when we get close together, oh no, those charges, right, are going to try to push each other apart. So we have more than one force that's going on. Our the denser our cloud becomes, and the denser the cloud becomes, right, the more important those charges are going to be. So if you're familiar with something called the Coulomb barrier, that's going to be kind of how close can I get two charged particles together under gravity before the electromagnetic force pushes them apart. So I don't know exactly the process in the real astronomy literature of how that magnetic torque works. Like, I don't know the math or the details, but that makes perfect sense to me, to be completely honest. Um, Another great thing to think about is like how modern fusion reactors are like trying to be developed. The main problem with modern fusion reactors is like we can make one, it just uses more energy than it makes. So it's not a great power source. Um uh and okay. And they are held together. They have to put them into a really intense magnetic field when they're trying to fuse. Usually, they're trying to fuse either deuterium or tritium. So that's going to be deuterium is hydrogen with the neutron, so a proton and a neutron, and then tritium is one proton with two neutrons. So yes, Boomer, you. This is isotopes in introduction. Um, and because of the nuclear strong force, adding in that neutron is really helpful for sticking those elements together. But like in modern infusion reactors, we're like apply magnetic torque. That's a real no joke thing that experimental labs do to try to force these guys together. Um, so the idea that it's magnetic torque, which would be, so a torque is like an angular force, right? So a torque produced by the electromagnetic force seems completely reasonable to me, of what's going on here. So let's see if he doesn't like that answer. Okay. Astronomers think that the interaction provides the torque. That magnetic interaction provides the torque. Stars, including the sun, have magnetic fields. Sure do. For that matter, the galaxy has a magnetic field that threads through the like medium, including any collapsing gas clouds. With rising temperatures, with a collapsing cloud, its material begins to behave as a plasma. This leads to an interaction that can transfer angular momentum from forming stars. Cool. Even mature stars have angular momentum loss. The sun takes about a month to rotate on its axis. The solar wind is a tenuous outrush of charged particles from the sun. As these charged particles move outwards, they are subject to the sun's gravity, but they are much more affected by the sun's magnetic field. Solar wind particles leave the sun with rotational motion that they had on the solar surface. As the particles move outward, their rotational velocity slows due to conservation of angular momentum. Meanwhile, the sun's magnetic field extends far from the sun, but the field must rotate approximately with the sun's monthly rotation. This results in the sun's magnetic field rotating much faster than the wind particles do. Since the solar wind particles are charged, the sun's rapidly rotating magnetic field exerts a force, a torque, on the wind particles, accelerating them. Newton's third law of motion dictates that the wind particles exert an equal and opposite force on the sun, slowing the sun's motion. Cool. Yeah. So, okay, so conservation of angular momentum is a thing, right? And in general, conservation of momentum is a thing. In any like closed system, the amount of momentum you start with is going to be the amount of momentum you end with. So, if I want to take momentum away from the sun, I've got to physically take something away from the sun, right? I can take that momentum away from the sun as long as I put it somewhere else. And that's all he's saying. that doesn't sound like a problem to me. Like, this just seems like a basic explanation of how a star can lose angular momentum. Um, uh, so Mary, is this paper trying to tiptoe around plasma cosmology, or is that just bizarre wording? I think it's just bizarre wording because he's not really talking about plasma cosmology. Anyway, we'll see. Because like plasma physics is its whole own thing. Okay. All right, let's open this. Okay. Do other stars have solar winds? Winds from stars similar magnitude. So it's hard to detect them from Earth. However, some stars are observed to be exceedingly windy, and I feel like nobody thought about the phrasing of that sentence. Okay, so other stars have solar winds, which can explain a loss of their slowing down. Not a loss of that star's angular momentum because we took that angular momentum away and put it somewhere else. So we're just gonna scroll through this and looking for okay. Great. Okay, so here a creationist source have shown that the rate of magnetic braking in close binaries is much faster than generally thought and may have implications in developing a young universe cosmology. That sounds boring. Other stars have strong winds, have strong solar winds, etc. so forth. Okay, so I don't. Okay, so here he's just explaining things. He's not trying to. He's not. What's hard here is like I'm trying to discern when he's saying like this is a thing and therefore it's a problem for traditional astronomy. And when he's just trying to say this is a thing. So cool. Love that. Anywho, I think he's just explaining this is a thing that exists. Okay, so the end of the star formation process. Eventually, the temperature in the core of protostars rises to the point that thermonuclear reactions begin. Absolutely. This is not a dramatic switch. Nope, it's going to happen slowly over time. For lower mass stars that can cause a change in opacity, sufficient to drive the forming stars nearly horizontally on that temperature luminosity diagram. Cool. Stars with more than 3 solar masses skip this track predicted by this guy in the 60s. Okay, we get to the same place in different ways. Once on the main sequence, contraction ceases and astronomers say that the star is born. Often one hears in the news an account of astronomers witnessing the birth of a star. Given the long timescales expected for star formation, such reports are misleading. Rather than directly observing star formation, these news stories refer to astronomers that either observed a star in their estimation variantly recently formed, or is a protostar still undergoing the process. These amount to snapshots that are arranged to fit the theory of how stars formed. No, sir. Absolutely not. That is not how that goes. That you've got that backwards. It's not that we decided this is how it goes and then found evidence to support it. No. This is not how that works. No. The way that works is we asked the question, how do stars form? Let's see if we can look at them while they're forming. Right? And we made some good scientific predictions to point our telescope at the right point at the right time to see some of these predicted processes. So we predicted a process that told us where to point our telescope, and then we pointed our telescope there, and then we saw the thing we predicted. Right? I say we, I mean the astronomers that did this research. Not I've already decided how things work. Now let me go find evidence go cherry pick evidence that supports that, right? That's not how this works. So he flipped the chicken and the egg in that sentence, and it bothers me. Okay. See, they're arranged so like, we just pointed our telescope at random points and then put them in a random order that felt good at the time to fit our theory. No, that is not how that happened. Okay. So now let's read his conclusions. It is not the intent of this review to promote mainstream theories of star formation, nor is this review necessarily intended as a critique of those theories. Rather, the purpose is to inform creationists on some of the details of this theory of star formation, something that has been lacking in the creationary literature for a very long time. The calculation based upon measured conditions within giant molecular clouds indicate that they are unstable against collapse. Therefore, the conclusion that star formation is possible, at least in some situations, seems unavoidable. I hope that this review can stimulate discussion, perhaps resulting in some consensus of how much, if any, of this theory recent creationists may accept. If all of it is rejected, it's important that we develop alternate explanations of the observed objects that are interpreted as protostars or even young stars. Cool. So this is consensus. I presented consensus scholarship. This is my summary of his conclusion. He's saying that like, oh hey, I presented consensus scholarship and totally not ever using misleading or deceptive language. And now we've just got to decide if like now we've got to decide based off theological reasons if we can accept this as real or not. And if we can't, boy howdy, are we going to have to do some work to explain all this away instead of, right, like if you can't reject it on scientific reasons, then you can't reject it, right? And exactly, Mary, they decide what they want the conclusion to be, then look for ways they can prove it, which is not how science works. That's not how traditional science works. That's how manipulation works. That's how bad science works. But that's not how good science works. Good science is objective, right? Or as objective as anything done by humans can be. Yeah. So to be honest, this wasn't so bad. And I think that's mostly because he wasn't actively trying to say, see, this can't be real. This is just like the general thing. There were a few places when he was trying to be like, oh, and this is a problem for, and because anytime he came to what I would describe as, and this is an open question in the field of astronomy, he described it as a problem, right? Like this is a big deal for astronomers. They don't know how this works. It's like, that's because it's an open question. That doesn't mean we will never know how it works. That means we don't know how it works right now. That means this is what we need to work on. And so he did do that several times. He definitely used a lot of misleading language in describing some of these things. I think we pointed all of that out. But like when he was, and I'm a little confused that he didn't cite, let's double check the references, because I don't think he cited any non-creationist sources from like after 1965, which, boy howdy, that was a long time ago. A lot of work has been done, you know? Yeah, and Silver, absolutely. So Yeckers go on to project onto scientists this conclusion first way of thinking because they assume that scientists must think the same way they do, and that's just not real. That's not how that works. Okay. So I'm going to take a look at his references because I really do want to see okay. Okay, so when he Okay. So we do have So Hubble Space Telescope from 2002, Astrophysical Journal. That might be his source for the picture, though. 1989, T-Tari stars, wild as dust. Okay, so we got something from 1989. 1890. Love that. Okay. Okay, so he is citing some stuff. Non-creationist literature that's relatively new. We've got a 2017 here. Our high redshift galaxy's hot in the Astrophysics Journal. Then we got a lot of Creation Research Society, answers, Creation Research Society. Let's see. Actual paper from 1966. Creation Research Society. 1955. 1902. Goodness gracious. Okay, but here we go. Oh, okay, because I skipped a lot over when he was talking about T-Tari stars. But okay, so it's not the citation isn't nearly as egregious as I thought it was going to be. So that's promising. That's good. I remember that one time I was in a debate with Kent Hovind before the whole abuse stuff came out. I didn't say this out loud, and I should have, but I was trying to not be snarky. I was trying to like always take the high ground so that he looked like an asshole, you know. But we were talking about how the moon formed, and I was just stating the generally accepted hypothesis that a Mars-sized body collided with the Earth and the moon kind of spun off of that. And he was like, he didn't like that. And I realized, and I was like, no, that's pretty much the accepted theory in astronomy and astrophysics these days. And he said something about like, well, I don't have time to keep up with the latest science. And then after the stream, I during the debate, I offered to like, hey, I'll send you some papers. I did send him the papers. Never got a response email to that. But the paper I sent him was like a review paper from before I was born, right? It's like, oh, okay, so in 30 years, you haven't had a chance to keep up with something when you like claim to be an expert on all forms of like evolution. Okay, well, I think we're done with that, and we've been going almost 2 hours. So let's put that away. I will hang out for like 10 more minutes with y'all. Do you guys have any questions for me? Or anything you want to chat about? If you do, please just do tag me in the chat and I should see it. I can keep a better eye on it now that I'm not reading that kind of mind-numbing article out loud. Let's see. If not, we'll try to do Saturday morning. I'll try to do actual Saturday morning science on Saturday next week. And I haven't quite decided what I want to do. I really want to talk about young Earth creationism and hypercanes, but I've got to find a good thing to review. A good hypercane thing to review, because there's kind of like young Earth creationism kind of uses them in two ways. One is as a way to solve the heat problem, which, spoilers, they don't. And I did a stream on Gossip Gibbons' channel about that a while ago. But then they also use them as a way to explain like where all of the rain for the flood came from, if as an alternative to like, and then a huge reservoir of water just collapsed onto the earth. And I would love to like tackle both of those in the same stream. No, I haven't been texting with my friend who, he's a postdoc now. He graduated from the graduate program I'm in. And he does hurricane research. So no, I haven't been texting him with like, theoretically, how big could a hurricane get? So I want to do that, or in a complete switch to a different world of pseudoscience. All right. So you guys know, maybe you don't know, I am obsessed with cults. A lot of the YouTube that I watch has to do with cults and MLMs. And one of the things that keeps coming up, especially in like MLMs or anything that's like new age, is crystal people. Listen, crystals are lovely. Please have a rock collection. Rocks are great. But this idea that like when they talk about like it's going to raise your vibrational frequency, and I really 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 want someone to try and explain to me what that means, right? I really want that to happen. Um uh do. Oh, silver, no, a hypercane, that's not a thing outside of young earth creationism. Every once in a while, like the term will come up because someone thinks they're being very clever and they just mean a big hurricane. Um, like if they're trying to do like worst natural disasters ever. And they'll try to like make up new categories for hurricanes, you know. Um, but no, it's really they're really I've only ever heard of them inside of young earth creationism, and my friend the hurricane researcher had never heard of them before. And so I got to explain young earth creationism BS to him. I think I made his night. I hope he was having a delicious beer at the time because I think he was dying laughing while I was explaining it. But it's like the one real weather thing that young earth creationism gets into, and I'm like, that's what I do. So I've got to find the right thing to review, and I would love it to be a video, but it could be an article if it needs to be. That didn't go too bad today. Yeah, Boomer, like that's the hardest thing for me about astronomy and why I ended up not being able to go into like planetary science is that like I couldn't imagine like, great, we're going to launch this instrument and 10 years from now we'll be able to go through the data. I just don't have the patience for that. So like God bless astronomers and astrophysicists and planetary sciences because they're way more patient than I am. And we need them. We need them, and I am not one of them. Yeah. So anyway, so I did find a video series that's like, I think it's titled Quantum Physics Explains or Proves what is the new age thing? Manifestation. So the idea that like, oh, what you speak out into the universe will come to you, right? You could just manifest success and fame and money. It's like, no, no. But I found, again, like I said, I found a video series. Oh, thanks, Corntech. Aaron Raw did several on disproving the Noah flood. He did one on meteorology. Perhaps knowledge and experiences could really build upon that with regards to YEC. That would be really cool because I could check out that Aaron Raw video and see if he was reviewing something or like what specific theory he was going on. So that's a great place for me to start to find a good thing to like review and react to, because these are way more fun when I'm not lecturing you guys, when we have something to watch or read together. I'm just making a note because if I don't write things down, I immediately forget they exist the second I end a conversation. Yay! Hooray, my brain. Raw meteorology YEC. Okay, that's a note. I'll remember how that works later. Cool. Excellent. Okay. Yeah, so I found a video series. It's like a 6-part series that's like quantum physics proves the law of attraction. That's what it's called. The law of attraction. That's like if you're positive things will happen to you and all that toxic positivity BS. And it's like, no, sometimes bad things happen to you, and you can be the nicest person on planet Earth, and bad shit will still happen to you. And good things will happen to you too. These are pretty random. Anyway, but I would love to see how quantum physics is supposed to prove that. That sounds like a fun thing to look at to me. Because we're against all forms of pseudoscience here at Science Side Up. Yeah. Okay. So other than so that's kind of what I want to. So that should be next weekend. Hopefully, I'll get like an edited video up this week. I think I've got to do one more Weather One video on like a specific term because we never talked about what's called wet bulb temperature, and wet bulb potential temperature is really important for skew T diagrams. And if we want to get into skew T diagrams to get a good sense of, it's a really great resource for understanding severe weather. And like, can I expect severe weather today? How nervous should I be? And so I really want to give that as a tool on my channel in my Weather 101 series. But we've got it. But I don't like those videos. If you guys have watching those videos, I try to keep them like under 6 minutes because they're just little bite-sized. We're going to be quick about them anyway. And so I've got to do that, and then I can get to the QT one. So I've written like 4 scripts. Now I just need to have a day when I can film. And you can't see behind me, but a friend of mine is having a baby in July, so I'm making a baby quilt for her. Sadly, no cuneiform on this one. But my sewing machine is all set up in front of my chalkboard behind me. Okay. And yes, Silver, hello. Quantum woo is the worst kind of woo. I love that in modern science fiction, if they want to make anything sound cool, right, they just put the word quantum in front of it. But like the same way in the 1950s, like the word atomic showed up, or yeah, like Atom Man was a superhero, I think. And if you watch, oh goodness, like, okay, so even like Night of the Living Dead, the zombies in that movie are created by like weird radiation coming from Venus and other stuff. So I love that just like radiation, atomic, and nuclear from to explain literally anything in science fiction in like the 50s and 60s has been replaced with quantum in modern day. Yeah, gamma radiation can apparently do anything. That's a great one. Nebulon, you've got great taste in TV shows. I love Stargate. I'm a big fan. An upsetting number of my life choices have been to make me more like Sam Carter. Okay. Well, team, I think I'm going to let you guys go. I hope you have a spectacular Sunday. I'm about to go get brunch with my husband. I'm going to have to put on some real pants and not my comfy sweatpants. And if you want to watch me and Dapper and Bent and Gossip Gibbon and folks play Dungeons and Dragons, we've got to deal with the fact that our Tabaxi rogue is under the effect of feeble mind and is basically a feral cat now and just keeps knocking things off counters. Well, that'll be Wednesday at 6 Central over on Cheshire Vic's channel. So you guys have just the best day, and I'll see you soon. Okay, bye team.